Hello everyone, welcome to the class of Digimento. So today we are going to solve some further questions of PYQs of GATE 2024 Computer Science. Okay, so this was the question which I have given you as homework. I hope you have solved this. Okay, so let's discuss the solution for this. Consider the operators this and this box shape operator defined by A operator b equals to a plus 2b, and box shape operator defines as the multiplication of that for the positive integers. So which of the following statements is are true? So here the options are also given to us. Now let's verify the options one by one. So the first operation they have given is, you have to note that the operation is like this and this operation is like this. So two operations are given. So through symbols they are trying to note that if the diamond shape is there, so a and plus 2 times of b will be there. But if a square shape will be there, so it will be multiplication. That is what you have to keep remember. Now after that, so you know that, so operation which is a hash, okay, is said to be associative if, when it is said to be associative, when a hash b hash c is equals to a hash b hash c. Okay, then they are associative, everyone. So let's check, let's observe from the first option whether it is associative or not. So how to check? First we are going to take for this a diamond, b diamond, c. Now this will be equals to what? So the inner bracket will be a plus 2b, and here diamond, c, correct? So this will be a plus 2b plus 2c. This will be like this. After that, let's see that let's change now. So a diamond, after that b diamond, c. Now let's check that whether it is giving the correct answer or not, or whether it is giving this is equals to. Okay, so let's check. So a diamond, let's solve the inner bracket first, which will be b plus 2c. After that, let's solve the outer bracket. So this will be a plus and 2 will be multiplied here into it. Okay, because as you have seen that the first one will be as it is and second one will be the multiple of 2. So this inner will be just multiplied by 2. So the answer we are going to get is a plus 2b plus 4c. Okay, plus 4c. So can you just compare now? Here a is correct, a is correct, 2b is correct, 2b is correct, but here 2c is there and here 4c is there. So can we say that option A is associative or it obeys the associative law? Absolutely not. So that is why A is not the correct one. Now let's check for whether this box shape obeys the associative law or not. So let's verify with the similar thing. Now I guess you can try this by yourself also very easily. So we have to see, to check associativity always 3 operands are needed. Okay, so the first one is, I am taking like this, a box b box c. Now it will be ab box c. This will be abc, correct? The second one will be a box b box c, and this will be a box bc, and this will be abc. Okay, this will be abc. So the result of this and this is absolutely same, that is why we can say that option B is the correct one. Okay, now let's understand what is a distributive law first. Okay, so let me define this. So associative law, this is associative law. Now let's understand what is a distributive law, and after that we will see the options. So distributive law means whenever we have this percent symbol and it is distributed over @ symbol. So I will explain you how. See, a percent b and here is @C. It is like this. So how it is distributed? Now this A will be with B, and this @ will be in middle, and in the other one it will be with C. Now I will write it. So it will be A%B like this. @ will now be in the middle because it is distributed. Again A%C. This is the distributive law. Now let's see whether it obeys or not. Okay. So the first one we have to check. So they are saying that operator this diamond over the product. Okay. So the product, over the operator, whether it follows or not. So that means A like this is over this B box C. It is like this, everyone. Okay. Now how it will be distributed? You can check this. Okay. And can similarly form for this. So it will be A diamond, B box will be in the middle, A diamond, C like this. Okay. Now can we just solve this? So this is LHS I am writing. Now let's check that whether LHS is equals to RHS. So this is LHS side. This is RHS side. They both should be equal. So let's apply. Now here box what will be the answer? AB. And this now A diamond AB. So what will be the answer? A diamond AB will be it is BC. So it will be A plus 2BC. This is our left hand side. Now let's verify for right hand side. So this diamond will give the answer as A plus 2B. This box will be there. After that, this will give the answer as A plus 2C. Okay. After that, this is saying, the box is saying that just multiply. So we have to multiply A plus 2B into A plus 2C. Now bracket multiplication, okay, this we have studied in the class 10th and even lower that from the 5th standard we know how to multiply the bracket, how to do the operation in Boolean algebra. Okay, so this is very easy. It will be A square plus 2AC plus 2AB plus 4BC. This is the answer from the RHS side. So can you check that LHS side and RHS side are equal? So here distribution law fails, right everyone? So that is why C is not correct. Now similarly, can you check for D everyone? So I am giving a minute time. So please check for D whether you can do it or not, and let's verify when I will be solving this. Done everyone? So this was the question, was purely on the concept of distribution and associative. Okay, so let's check for D. So here the equation will be formed like A, this box, and B diamond C. Now this will be distributed as A box, B diamond, A box, C. Now LHS and RHS, let's solve this. So A box diamond will be solved as B plus 2C. After that, multiplication will happen. So AB plus 2AC. This will be the equation we will have, right? Let's see for this as well. So this will be AB diamond and this will be AC. So again AB plus 2AC. Now you can check that they both are absolutely equal. LHS and RHS side are absolutely equal. They are not different. So here D is the correct one. Okay, and they're asking for the true answers. So which are the true answers you will select? B and D. Okay, everyone. So B and D are the answers you are going to select. So this is correct and this is correct. So I hope you got this question. Let's solve this question now. So read at least once this question properly so that whenever I will explain, you will get everything. So read this properly. This is a question of computer architect. Okay, so let's understand this. Consider two set associative cache memory architectures. WBC, which uses the write back policy, WTC, which uses the write through policy. Both of them use the LRU, least recently used block replacement policy. The cache memory is connected to the main memory. Which of the following statements are true? So they are asking for the true statements. So first statement is a read miss in the WBC, which is write back policy, never evits a dirty block. So this is absolutely false. Why? Because when we miss accessing data in the cache, either by writing or reading, we can choose whether or not to add that missed data into cache. So sometimes we might sometimes we might not decide to add it because the data is already in the cache from the another memory location, which is more useful or more often accessed. So this is absolutely false. So we can say that this is false because it says that a read miss in WBC never. So never is not correct. Okay, which is not in the case. So that is why this is false. Now let's see for the B. A read miss in WTC never triggers a write back operation of a cache block to main memory. So in the write through policy, data is always kept in synchronized. Therefore, we never need to perform a write back operation to remove any entry from the cache. And this makes the option correct because it says that never triggers a write back, which is absolutely correct. Okay, so B is correct. Now if we talk about option C, a write hit in WBC can modify the value of the dirty bit of a cache block. So in a write hit in WBC can modify the value of a dirty bit of a cache block. So if there is a write hit in WBC, it means that we are writing directly into the cache. So of course we will also change the dirty bit. Okay, so that is why C is correct. Now let's talk about D. A write miss in WTC always write the victim cache block to main memory before loading the missed block to the cache. So there are two blocks mentioned. First is, which block is mentioned? First is victim, okay, miss block and victim cache block. So the miss block is the one we want to access, while the victim block is the one which is getting replaced by LRU. Okay, so when there is a write miss in WTC, it means that the data we are trying to write is not in the cache. Now we may want to upload it into the cache, or we may not to. Okay, but suppose we don't want to bring it into the cache, so in that case we can directly modify the main memory. So however, if we decide to bring it into the cache, then we may or may not need to replace the victim block depending on the cache is already full or not. So that is why this is also false. So we can say here that option B and C are only correct. Okay, I hope you have got this. If you have any doubt, you can just comment it below. I will be solving your doubt. So there is no issue in that. Okay, So see this question everyone and try to solve this. So take your time, 1 minute. This is a formula based question and try to solve this everyone. Okay, so done everyone. Should we solve this now? Yes, so this is an operating system problem. Okay, so let's first see how to solve this question. I will tell you. So if I were in your place, how would I have solved? I will tell you that. Okay, so first in such question, I generally note what is given. Okay, so the first thing is given to us is hard disk capacity, which is 512 GB, and we all know that this is not what we want. We always want this in 2's power. So 2 to the power 9 and 2 to the power 30, because gigabyte is represented as 2 to the power 30. So this is basically 2 to the power 39 byte. Now this is what is of our use. Second is they have given number of surface. So number of surfaces 32. Again I will write it as 2 to the power 5. Now they have given sector track 4096, which is 2 to the power 12. Then they have given sector size and capacity, which is 1024, which is 2 to the power 10 byte. Okay, and they are asking fifth, number of cylinder is x. Number of cylinder is x. And from this what we know? Okay, so we know that disk capacity is equals to number of surface, okay, into number of track or surface into number of sector track into number of byte sector. Okay, so this is what we know. Now let's carry forward this on the next page so that we can solve the calculation. Now you understood how to solve such question, and trust me, with this method it will not even give you the wrong answer, because already everything is written. Now let's put whatever we have. Okay, so disk capacity we have. Okay, this is we have 2 to the power 39. After that, number of surface also we have 2 to the power 5. Number of track's surface, this is cylinder, nothing but, so it is x. After that, number of sector per track given 2 to the power 12. After that, they have also given number of byte per sector, which is 2 to the power 10. So this is 2 to the power 39. Now if you just write this 5 plus 12 plus 10 into x like this, so 2 to the power 39, and this will comes out to be 2 to the power 27 into x. Now if you just divide this, so 2 to the power 39 by 2 to the power 27, so this will be x equals to 2 to the power 39 minus 27. So it will be 2 to the power 12, and 2 to the power 12 is nothing but 4096. So that means number of cylinder, they are asking the number of cylinder in the hard disk is, okay, it was our x, so it is 4096. Okay, so very easy question, formula based. What is given that you have to write, and after that what we want, what we know, the formula that should be written. Okay, so definitely always if you follow this trick or if you follow this way, definitely you are going to get the correct answer. Okay, now solve this. Solve what is given to you, what you know, and how you can attempt. Everything, if it is given in the paper, everything if you are if you have written in the paper, definitely the logic will work. You will remember something, okay? But just overlooking this again and again will not give you some idea like how to proceed, how to solve the question. This will not give the idea, okay? So write what is given, what you know, write. Automatically you will find the way to solve the question. Okay, everyone? So just do it. Giving a minute time. Read at least properly. Okay, so let's solve this question, everyone. The baseline execution time of a program on a 2 gigahertz single core machine is 100 nanoseconds. The code corresponding to 90% of the execution time can be fully parallelized. After that, the overhead for using an additional core is 10 nanoseconds. When running on a multi-core system, assume that all core in the multi-core systems run their share of parallelized code for an equal amount of time. The number of cores that minimize the execution time of a program is. So, So look at this carefully. This question is quite tough. Okay. So the code that cannot be parallelized run for 10 nanosecond. Okay, given to us. For every additional core, additional 10 nanoseconds overhead is added to the total execution overhead of n cores is n minus 1 into 10. Okay, so I'll be writing this systematically. Just look at this properly, okay, everyone. And how I am writing this, just see that, okay. Okay, so let's solve this problem on the next page. That will be nice. Okay, so what is given? Baseline execution. Baseline execution time is 100 nanoseconds, already given in the question. So program that can be parallelized is 90%, which is that is 90 nanoseconds program. Okay, after that they have also given us overhead cost of additional core, which is 10 nanoseconds. Okay, now the execution time for n core, which is equals to parallelized time by n plus fixed time plus overhead time into n minus 1. Now T of n is 90 by n plus 10 plus like this n minus 1. After that again we can do T of n is equals to 90 by 10 plus 10 10n, if you just simplify this properly. Okay, so to minimize the derivation, let's take Tn, T of n equals to 0. So the equation will be continued as okay, so that will be so if that becomes 0, okay, so it will be 90 n plus 10n equals to 0. Now if we just put a constant, so what we will do, n into n into n, and this, so basically we are dividing, so here also we are dividing, here also we are dividing, and here also. So this will eventually be 90n square plus 10, and this will be 0. Okay, any doubt here till now? Or if you have any confusion here in this case, so what you can do, you can put the t value and you can check what is the answer coming. Okay, instead of doing this, you can also put the t value and can check, like this here also. So let's copy the equation. So this is the equation we have got. Okay, so you can simply check by just putting the value. Let's say t of 1. So t of 1 will be 90 plus 10, 100 After that, T of 2 will be 90 by 2 plus 20. So this will be 65. T of 3 will be, okay, so T of 3 will be 90 by 3 plus 30. So this will be 60. After that, T of 4 will be, if you calculate 6.5, T of 5 will be 68, and like this it will be so on. Okay, but we want the number of cores that minimize the execution of the program. So what do you think is minimizing the execution of the program? You can say 60. Okay, so out of all this, which is the minimized one out of all this? Can we say at time 3 it is 60? Okay, so that is why 3 is the correct answer. So like that also you can check. So 60 nanoseconds is the minimum one, okay, at 3. So that is why 3 is the correct answer. Okay, everyone. So that is why here we can say that 3 is the correct one. So this was a little a question which needed a lot of thinking, okay. But if you have solved PYQs like this, so definitely you will have some intuition how to solve the question. So that is why solving previous year question, and not just solving but by understanding the concept, is very very important. Okay. So try to solve this question, everyone. Just giving a minute time, at least read the data properly, whatever the data is given in the question, so that whenever I will explain, so it's not that you are sitting blank. Okay, you should understand what I am explaining. So just read the question properly. Okay, so let's see this. A given program has 25% load store instructions. Suppose the ideal CPI, which is cycle per instruction without any memory stalls, is 2. The program executes 2% miss rate on the instruction cache and 8% miss rate on the data cache. And after that, the miss penalty is 100 cycles. The speed up round off to 2 decimal places we want, achieve with a perfect cache, okay, that is with no data or instruction cache misses is. So first we have to understand that we have let's assume that there are 100 instructions. Okay, so let's assume step by step we will solve this. There are 100 instructions. 100 instruction. Okay, so we have 100 fetches for 100 instruction, and this will come from the 100 from the instruction cache. Okay, now the second they have given is 25%, that will be, that is 65 instructions, okay, are data fetch, or we can say store instructions, comes from data cache. Okay, so in total 100 fetches, we will have 2%, that is 2 misses, okay, of 200 cycles penalty as given in the question. So from the data stream, okay, let's continue this. From data stream, 8%, that is 2 misses, will be 200 cycles penalty. So total cycles taken to execute 100 instructions is 100 into 2 plus 200 plus 200, which is 600 cycles. So the CPI here will be 600 by 100, which is 6. So in the perfect caching solution, we will have 0 miss, and that is why the CPI will be by default 2 CPI. Okay, so the speed up achieved will be 6 by 2, that is 3. Okay, so that is why 3 here is the correct answer. Everyone got it? So CPI with a perfect cache is 2. So any doubt? I hope there is no doubt. Let's see the next question now. So read this properly. Okay, so let's solve this question. See, consider the following code snippet using the fork and wait call system call. Assume that the code compiles and runs correctly and the system call runs successfully without any error. So int x is given 3 and here 3 is so when it is less than 0, this while will stop. Fork is there, print hello is there, wait null is there, x minus minus is there. So the number of times printf statement is executed is. So for this question, we have to unroll the loop. Okay, we have to unroll the loop. And how we can do that? See, x equals to 3. So a fork call will be there and a hello will be there. You can see that. Now this is 3. Fork will be there, hello will be there. Okay, wait and this let's not write, that is not important. After that this minus minus will happen, that means x value will become here 2. Okay, again fork will be there and hello will be there. After that again the value will be reduced from 2 to 1 it will be. Okay, so x equals to 1, so fork hello same. After that 1, so 1 will get 0 and the loop will end. Like this the loop will end. Okay, so let's see how it is now executing. So basically what are we going to get? Let's see this properly. From this, so one line we are going to get properly like this. See this line properly. Okay, this one. So here x3, after that fork is there, after that print is there. Okay, again for 2 fork call is there, after that print is there. then again fork is there, and print is there. Sorry, print will be like this. Here also. Yes. Now what will happen for this particular fork call? So let's see from here. So this fork call, again here, from this fork call again we will have a print. Okay, from this particular fork call, what will happen? From this particular fork call, we will have a print. We will have a print. We will have a fork call inside, which is this one. Again, for this we will have print, and this fork call will have print again. Right? For now, for this fork call, what will happen? So just see this carefully. Print is there, print will happen. After that, fork is there, okay, which is there. After that, again print is there, again fork is there, and again print is there. Now this will print, okay, and this particular fork will print. Again fork is there, and print is there, and this is again going to print. This is again going to print. So I hope the diagram is clear, and this is how it's the way to solve. Okay, I can make the other diagram as well for you all if you didn't understood this. But let's try to see this. So how many prints are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so how many times it is executed? Print 14 times. So that is why, what is the correct answer? 14 is the correct answer. This is a way, and the next way is a tree form. Okay, so let me explain that also. This is one way. The second way is like this. So here parent is there. After that, for x equals to 3, let's see. So parent calling is there. Then it will be x equals to 3. So for x equals to 3, fork will be there. Okay, fork call will be there. And after that, from here, we will have a child call. Okay. After that, a parent call as well. So from here also, parent call. Okay. Then we will have x equals to 2. And here also x equals to 2. And here we will have a fork call. After that, child call. Again, child call for this. Okay, so this will be a little hectic for you. It's better that you solve from the above one. Okay, so I don't think that you will get this. So not for the confusion, just avoid this and stick with this. This is more easy to solve. So yeah, try to solve this question, everyone. So read the question very properly. So consider the entries shown below in the forwarding table of a IP router. Each entry consists of IP prefix and the corresponding next hop router for packets whose destination IP address matches the prefix. The notation n in a prefix indicates subnet with the most significant n bits set to 1. So here are the prefixes and here is next hop router. Okay, and this router forwards 20 packet each to 5 hosts. The IP address of the host are these are the given. Okay, the number of packets forwarded via the next hop router R2 is what? So it's a very big question. Okay, let's solve this. First, in order to find how many packets are forwarded via the next hop router R2, first we need to check that how many hosts are passing through the subnet 10.1.1.25. Okay, so in order to do that, we need to first do the following step. So step number is find out the total range of network. Second is we have to check in which range does the host lie. And third is if more than one network are matching, then select the network with the longest prefix, that is the value of n. Okay, so first we have to note the range of this. So first is the subnet given to us 10.1.1.0. So this range will be from 10.1.1.0 to 10.1.1.255. Okay, and this will be in the R1. The second here is 10.1.1.128 25, and the ranging will be from 10.1.1.128 to 10.1.1.255, and this will be in R2. The third is 10.1.1.64. Okay, this will be from 10.1.1.64 to 10.1.1.127, and this will be in the R3. After that, the fourth one is there 10.1.1.192 to 26. After that, 10.1.1.192 to 10.1.1.255, and which is for R4. So for host 10.1.1.16, it lies in the range of subnet number 1. Okay, and so it will pass through from the router R1. So this is for the first one, right? Second, for host 10.1.172, it will lie. So you have to check here. So it will lie in the range of the subnet number 123. So since prefix length of the subnet 3, which is 26, is greater than the subnet 1, which is 24, that is why the host IP address will pass through R3. After that, for host 10.1.132, it will lie in the range of subnet 1 to 2. But again, the prefix length of subnet 2 is 25, which is greater than the subnet 1 of 24. That is why the host IP address will pass through by R2. And similarly for 10.1.1.191, it will pass through the router R2. And for host 10.1.1, 205, it will pass through R4. So in total, two hosts have their next hop router, which is R2. So the total number of packets transmitted through R2 will be 40. Okay, so this is about, if you will observe this carefully, definitely you are going to know. Okay, everyone. So the answer for this is 40. So solve this question. Done everyone. Let's see how to solve this. So the thing you should know here is for CNF, for CNF, number of steps required is 2 length of string minus 1. Example also we can take here. So like if S is AA and A is deriving A, so for string AA we will need SAA, and after that here AA we will replace and this will give us AA. So how many steps are needed to derive this? So total 3 steps are required. Okay, so the number of steps to derive string is 3, right? And now here how many steps are there? So in our question W 90. Okay, the total derivation will be of 90. So if we put that into formula, so in this formula, so it will be 2 into 90 minus 1. 2 into 90 minus 1, and this will be 179. This will give us 179. Alright everyone, so this is the way to solve the question. So the answer here is 179. If you have any doubt, you can comment it below. I'll definitely answer and we'll try to solve the problem you are facing. So solve this question everyone now. Okay, so let's try to solve this question. Solution. The number of edges present in the forest generated by DFS traversal of an undirected graph G with vertex with 100 vertex is 40. The number of connected components of G is. So given a forest has 100 vertices and 40 edges, a tree with 100 vertices has 99 edges. To convert a forest into a tree, number of edges that should be added, which is equals to number of components minus 1. Okay, and if we assume that the number of components is x, so the equation here it will be formed as 40 plus x minus 1, 99. So x will be 60, right? X will be 60. So this is one way. This is one way. We can also solve by the other way. So let me write the answer as 60 here. The other way is according to Euler's generalization formula for any planar graph. So I will write Euler's generalized formula for any planar for any planar graph, which is, the formula is, so I will explain what is this VF. Yeah. So V is the number of vertices, F is the number of faces, E is the number of edges, and C is the number of connected component. So since every undirected forest is planar graph, is planar graph, is a planar graph. So C equals to, we want C, right? V plus F minus E minus 1. So can you all calculate here as well? So it will be 100 plus 1 minus 40 minus 1. The answer is 60. So this is the another way to solve the question. Now just understand few points here. A planar graph is a graph that can be drawn in such a way that no edges cross each other. Like if this is the case, this is not planar because they are crossing each other. But if you draw this way, then this is a planar. Why? Because no edge cross is there. After that, in any planar representation, face of a planar graph is region bounded by edges, including the outer infinitely large region as well. So here how many regions are there? One, second, and infinitely large. So this is the third one. Okay. So it's basically the area which is bounded by edges. After that, for every undirected forest has only one face, infinitely large region, okay, region which is not bounded by any edges. So please keep these points, remember, very very important for you all. Okay everyone. So for the homework you can note this question. So note this everyone. Note this. This is the homework question. Try to solve this. And if you have any doubt, please comment it below. In any of the question, if you feel that I haven't understood this step, so I'm going to explain that. And there are more such playlists for the other questions also. Not playlists, the videos are created for all the solution of GATE 2024 CSE. So you can see that videos as well. So every question, as I said, I have recorded in a very detailed way. So if you have any confusion, just go by the videos present in the channel. Okay, it is very very helpful because eventually it will tell you the pattern and how the questions are asked. Very very important. So take this as the homework question and try this. Definitely we are going to see all the questions and completely 2024 is covered in the videos. Do check it out everyone. Okay, so see you in the next video. Thank you so much everyone.